The quadratic formula is used in solving quadratic equations. The equation must be in this setup. I have to have 0 on one side. And then x would be negative b plus or minus the square root of b squared minus 4ac divided by 2a. Make up any equation you want, and let's solve it using the quadratic formula. Just give me any equation. Say it again.
14x squared plus 7x plus 2.
Awesome. It has to be equal to 0. Correct. Good. So then x equals? Very good. Plus or minus the square root of?
49.
Very good. Minus 4 times a
14
times c divided by 2a, which is 28. Okay, so then x equals negative 7 plus or minus. Unfortunately, it will be negative. So if you calculate 49 minus 14 times 8, that is negative 63. So the square root of negative 63 divided by 28. This is not real. Allow me to make a minor change because I would like to illustrate with a calculator also. So I'm going to keep your equation, but I'm going to change 2 into negative 2. Okay, so everything else is fine. It's nothing wrong with this, but it just doesn't have real solutions, and I cannot illustrate with a calculator. So then x would be negative 7 plus or minus the square root of 49, but plus 4 times 14 times 2. Because 2 is negative, I changed the sign into positive. And let's say we are okay with approximations. So let's look at, if you have your calculator, if you'd like to do this with me, I forgot to mention something very important. When I put this in the calculator, I have to have parentheses around the numerator and parentheses inside. Some calculators pop up with them, some calculators don't need them. I'm old-fashioned, I put parentheses everywhere.
No, everything went up so easily.
Everything okay? Good. So left parenthesis, negative 7, and then plus the square root, parentheses, 49, plus, I'm going to say 14 times 8, because that's what it is. Close the parenthesis, go outside the radical, and divide by 28. Now I want to determine the other solution, so I simply go back and say second and entry. And I overwrite plus into minus, by minus. Change plus in front of the square root by minus. And enter. So the two solutions approximated, approximately 0.2032 and approximately negative 0.7032. Now, if I'm not allowed to approximate, then I will just multiply 4 times 14 times 2 and add to 49. And I get 161. So then so this is approximated. And the exact solutions will be negative 7 plus or minus the square root of 161 divided by 28. And that is the exact. In order to see how important factoring is, so these are the 4 methods. If you ask me, okay, which one do I use when? Here's what I will say. If I'm not forced to use a particular method, I will do this. I will factor if it takes a blink to factor. I will use the quadratic formula if it's not factorable. And I will always take the square roots if the equation permits that, if it's a typical case in which taking square roots will give me the solution right away. Complete the square? Never. It's not a method for this. It's something very useful for something else, for conic sections actually. So it's totally legitimate method, wonderful, but not for this. I would like you to choose a problem to illustrate from here. And this, I'm kindly asking you to solve all the other problems. The answers are here. You just have to make sure you get to the correct answer. So please choose one. This is the supplement simplification by factoring. So please choose any problem you want so we can illustrate this today. Any preference? Okay, I will choose. I will choose number 4. So 4, 3x plus 1 cubed times 3, 2x minus 5 to the third plus 3x plus 1 to the fourth times 3 times 2x minus 5 squared and times 2. How many terms we see in this equation?
I want to say 12, but that feels wrong.
Of course it is. Because we know the difference between terms and factors from last time.
So then there are just 2 terms.
Awesome. Thank you. There is one term, and here's the other. Awesome. Thank you. Now, I will rearrange a little bit these 2 terms so I can work with them better because they are kind of spread all over the place. I will multiply 4 by 3, and I get 12. 3x plus 1 cubed, 2x minus 5 cubed. I will multiply 3 by 2 and get 6, and 3x plus 1 to the fourth, and 2x minus 5 squared. So I have to be honest, like I think always with you, and say, I will re-emphasize what I said. Factoring for quadratic equations is not such a big deal, but factoring as a skill is extremely important because here, without factoring, I would not be able to simplify. So let's take a look. What do these 2 terms have in common? First of all, we start outside. I see a 12 and I see a 6. So the common factor is
6.
Awesome. Then I see a 3x plus 1 in both. So I will choose 3x plus 1. Which power do I choose? Yes, the smallest of the 2. Awesome. I also see a 2x minus 5. Which power do I choose for this factor? Awesome. What is left in parentheses? What is left and how many terms? Mandatory, how many terms? Yes, because I started with 2. Absolutely. So somewhere I will have plus. Something coming out of the first term and something coming out of the second term. Awesome. Good. So then from 12 I took a 6 out, so what is left? 2. These are completely out. 3, 3, correct? Now from these 3 I took out 2. What is still left in here?
1.
One of those. So parentheses 2x minus 5. Perfect. What is left from the second term now? So 6 is completely out. 3x plus 1 is in. And is there anything left from 2x minus 5? No. Now I have to combine like terms in here, and it's done. 6, 3x plus 1 cubed, 2x minus 5 squared, 4x minus 10 plus 3x plus 1. Combine like terms, and it's done. Yes. Yes. 7x minus 9. See, we could have not been able to factor this without having or understanding factoring. We do prefer factors over terms, as we mentioned last time. Why? So one application was in solving equations. Once we factored the polynomial, once we factor this, we were able to solve the equation. Any questions for me? Any questions? So let's work on this now. Open notes, open book. Just not your colleagues. You're welcome. Tommy, have a pencil?
And
Or whatever it is, something to write on.
Yep.
Something to write with, I should say. Thank you. I didn't forget about you.
I guess how we're ending the class.
It depends. If everyone finishes in 1 minute, then no. But you cannot use any devices, you cannot use your cell phone, you cannot. Yes, you can use your calculator, but no, not your cell phone or computer. So let's say about 12 minutes.
second.
Thank you. Thank you. Thank you. Very good. You will not be. Thank you. Thank you. Thank you. You can write it, and I know you will not be there. Yeah, only this time. Yeah, so I know. This is also a way for me to take attendance. Is that what, 1 minute? I like to look at a word problem that uses quadratic equations. And since we have 10 more minutes, maybe go back and work on a complete the square or anything else that you would like to practice. Thank you. Done? Thank you. Thank you. Okay. So let's choose a word problem. I have my book here on page 169. Let's say 145. The length of a rectangular sign is 3 feet longer than the width. Length is 3 feet longer than the width. Okay. The sign's area is 54 square feet. Area is 54 square feet. Find the length and the width. And no, just choosing two numbers and showing that such and such, that's not going to get credit. So you have to present a mathematical way of solving this problem. So first I'm going to draw a rectangular sign. I'm going to denote this by length and this by width, so L and W. You can use any variable you want, or any variables you want. Don't have to use L and W. And I'm going to try to express this sentence in an equation. Can anyone have an idea for us on how to?
Y equals x minus 3, or x plus.
So now if we use L and W, we stick with L and W. If we change into Y and X, I'm fine, but
Alright, so W equals L minus 3.
you could. That's fine too. But let's just mimic what we see here. It's correct. You will get full credit. Okay? But let's change the length into L. What does is represent in mathematical terms? Equals. Very good. 3 feet longer than the width. Say it again. Very good. Awesome. So this is done. So that first equation, the first sentence, yes. And what Brian said is fine. He said L minus 3 equals W, which is perfect. Same thing. Okay, now the area is 54 square feet. How do I express that into an equation?
L squared plus W squared.
But area is just length times width. Yes, L times W equals 54. Okay, what do I do next? I have two equations, and I know that L or W plus 3 mean the same thing.
Find an ordered pair that satisfies both those equations.
No,
Maybe not.
I will substitute. I will substitute L in the second equation by what it equals to, and it equals W plus 3. So then the new equation number 2 becomes what?
W squared plus 3 should
I have to show first that W plus 3 times W equals 54. Then the next step would be, yes, indeed, W squared plus.
3W.
Very good. Yes, and then minus 54 equals 0. Yes, you can write that other step. That's fine too. And now, remember I have 4 methods. Which method you will not apply here for sure?
Completing the square.
Which other method you will not apply here for sure? No, that's okay. That's okay. No, that's okay too. Which other method does not work here in this scenario? Taking the square root, right? I can't take the square root from a sum. So either factor or quadratic formula. But it only takes a blink to factor. Why not? So how do I factor? Awesome. So then there are 2 possibilities for W. And you could say, not so fast. But what are the possibilities for W? From here, 6 feet. And from here, negative 9 feet. And this one is not an option. A distance cannot be negative 9 feet. So if the width is 6 feet,
The length is 9 feet.
then the length is indeed 9 feet. Perfect. That's true. Any questions? We have 5 more minutes. Let's practice something else, something that we covered today or last time that you would like to review, go back to, completing the square or anything else, quadratic formula or solving rational equations. What would you like to go back to? What do you feel like doing?
Can we do another one of those long ones from the craft time worksheet?
Oh yeah, of course, yes, please choose. So please choose. We completed 4, so let's choose another. And please do all the others for yourselves. Which one? 7 it is. So let's do 7. So 4, 2x minus 3 cubed times 2, 5x minus 1 squared minus 2x minus 3 to the 4th times 2, 5x minus 1 times 5, and everything over 5x minus 1 to the 4th. Can anyone explain or tell us or give an example of a terrible mistake that someone could make with this problem? Something terrible.
Crossing out
Crossing out,
the 5x minus 1s on both sides of the fraction bar.
you mean, what do we mean by the both sides of a fraction? I'm not sure.
Okay, so you take the
You mean the
5x
top and the bottom?
Yes,
You,
the top and
okay,
bottom,
okay.
canceling them out.
So canceling this with this.
Yeah.
Yes, that would be a terrible mistake. Why? Because these are how many terms? 2 terms, and I cannot simplify terms or portions of terms. Correct. Awesome. Thank you. Good. So I look at the numerator, and I realize that it's a little bit all over the place. I will rearrange it. 4 times 2 is 8. 2x minus 3 cubed. 5x minus 1 squared minus 10. 2x minus 3. 5x minus 1 to the 4th and to the 1st power. Making sure that I copied everything correctly. Yes, I think I did. And 5x minus 1 to the 4th. Now I go back to the numerator. And I will factor the greatest common factor. What is the first step? I look at the numbers outside. I see an 8 and a 10, and they do have a common factor. Awesome. What else is common to both terms? Remember, we have 1 term here and 1 term here. Yes, 2x minus 3. Which power will you pick?
3.
Indeed, the smallest of those 2. Then,
5x minus 1.
and then 5x minus 1, which power?
1.
1. Very good. What is left from the first term? Yes, a 4 is left. Do we all agree with 4? Okay. So again, these 3 are completely out. And now from power 2, I removed 1 of them. So what do I have in parentheses?
5x minus 1.
Acceptable? Everyone? I reached this symbol. I have to copy it. From 10, I took out a 2.
5.
5 indeed. 2x minus 3 to the fourth, I took out 3 of those. 2x minus 3. And 5x minus 1 power 1, 5x minus 1 power 1.
Already taken it out, it's gone.
Is this okay? Yes, everyone? Were you able to follow? Okay, so now all I have to do is combine like terms. Yes, at this point, I can say this. Because I'm simplifying factors. I'm not simplifying terms. So then 2x minus 3 cubed, and now in parentheses, 20x minus 4.
Minus 10x plus 15.
Awesome. Maybe Alex, you shouldn't be in this class. You should be in pre-calculus. Never mind. Okay. Okay, you need to be in this class. Good, awesome. So then 20x minus 10x is 10x, and negative 4 plus 15 is plus 11, and that's the final form, and there is nothing else we can do here. No one can further simplify this. There is nothing else